These notes are on multiplying complex numbers. So the first thing we have to do is we have to decide what are we going to do when we multiply complex numbers. So we know that I means the square root of -1, and we rewrite that always as just I. But the question then comes up of, well, what does I squared mean, I cubed mean, I fourth, etc. So I squared means the square root of -1 squared. And the square root of -1 is -1. I cubed I can rewrite as I times I squared. We know that I is I, but we also know that I squared is -1. So I times -1 is -I. I to the fourth, we know we can rewrite as I squared times I squared. We know that I squared from above is -1, so I have -1 times -1, which is +1. Now, I then can rewrite, really the lesson here for the I squared, I cubed, and I to the fourth is that I can rewrite I to any power, breaking it down into smaller powers. So I can rewrite I to the fifth as I times I to the fourth. But I know from above that I to the fourth is 1. So I have I times 1, which is I. I to the sixth I can rewrite as I squared times I to the fourth. And I know that I squared is -1. And I to the fourth is +1. Which means I to the sixth is -1. I to the seventh, I know that I can rewrite as I times I to the sixth, but I know what I to the sixth is. It's -1. So I to the seventh is -I. I to the eighth, I know that I can write that as I to the fourth times I to the fourth. So that is 1 times 1, so 1. Now I'm looking at this and I'm seeing some patterns here. I mean, I'm only getting, when I simplify I to any power, I'm only getting either an I or a -I, or -1 and a +1. And not only that, but the pattern is repeating. I've got I, -1, -I, 1. I, -1, -I, 1. And so that every fourth time, I go back and I start at the beginning of the pattern. Which means that instead of using all of this work that I've been doing here, I can actually simply say, well, I to the ninth is starting my pattern again. It's back to being I. So my answer is going to be I. So another way to think about this is to pick out a whole bunch of I to the fourths. Get rid of I to the fourth, as many as you can. So I to the ninth is going to be I to the fourth, 2 of them, leaving you 1 I. But we know I to the fourth is 1. When I square that, it doesn't change it, so I get I. Now, it's important to recognize that earlier in the module, we talked about the meaning of the square root of 2 numbers being multiplied, that I could rewrite them as the square root of the individual numbers being multiplied. However, something we didn't necessarily talk about there that's really important is that that only is true when both m and n are that is true only when both m and n are positive. I apologize for that mistake. I'm sorry. It is true only when both m and n, when both m and n are not both positive. So I've got the language here is definitely a little confusing. So let me see if I can reword that. So we'll say that the square root of m times the square root of n equals the square root of mn is only true when both m and n are not, so maybe we won't say both here, is true when m and n are not both negative. So if m is negative and n is positive, this is true. If n is negative but m is positive, it's true. If both are positive, it's true. The only time it's not true is when both are negative. So we'll look at that example right here. So it works out, I'm going to do this two different ways so we really can see how this plays out. So if it were true that this relationship works when my numbers are both negative, so if square root of m times the square root of n equals the square root of mn works for m and n equaling a negative number, then this would equal the square root of positive 36, which is 6. So let's try it the other way. Let's say that they're not equal. Well, I know from the work I've done previous that I can rewrite the square root of negative 4 as I times the square root of 4, and negative 9 as I times the square root of 9. I know that I times I is I squared. Square root of 4 is 2. Square root of 9 is 3. So I end up with 6i squared. But I know that I squared is negative 1. So I get negative 6. So there's a discrepancy here. There's a contradiction. It can't be that the answer is both at the same time positive 6 and negative 6. So mathematicians had to come to a reasonable conclusion about which was going to be the correct answer. And in order for the system to be consistent, they decided that it was the negative 6. So that the square root of m times the square root of n equals the square root of mn is true only if m and n are not both negative. So what I often tell students is that whenever you have a square root of a negative number, simplify the i's out first. And then you're not likely to make mistakes in terms of whether or not we're agreeing if the square root of a negative times the square root of negative is the square root of a positive or not. You're just simply taking care of those i's as your first job. Let's look at an example, a second example that you will often see when you're multiplying i's. And the other most common problem that you'll be given is you'll be asking to be multiplying two complex numbers, so an a plus bi and a c plus di. And this multiplication is the same that you would have done if you had two binomials being multiplied. So I just do a double distribution, 2 to the 8 and 2 with the negative 5i, so I've got 16 minus 10i. And then my 3i with the 8 and my 3i with the negative 5. So that's 24i and negative 15i squared. I can combine the like terms here in the middle, so I get 16 plus 14i. I also know that I can simplify I squared, so I know that that is negative 1. So now I have 16 plus 15 plus 14i. So I've got 31 plus 14i. 2 plus 3i quantity times the quantity 8 minus 5i is 31 plus 14i.